Hey guys, how are you doing? Last time we stopped at 10%, so let's continue from here. So we were going through the Python course, and I want to do this challenge and just try to finish Codecademy as fast as I can while trying to explain what's going on here. Okay, so now we're doing explicit string conversion. So I have a plus coconut, so this would basically write out I have 2 coconuts. Okay, so if I took this and like I was showing you guys, whoops, that's not what I meant to do. If I opened up my terminal here, and let's make the screen a lot bigger so you guys can see clearly, and let's open up I'm trying to open up Python 2. And if I do Python here and I tried this line, you see I have 2 coconuts. Okay, another website I want to show you guys that's really great that you can use to use a terminal just in case you're having some problems or you're using Windows to follow along. You can use this website called Repple. Okay, and in this website you can pretty much choose what language you want to use. So here, let's say you want to use Python 3. So you can write the same thing down, except in Python 3, print is a function, so you have to put parentheses around it. And let me make this one bigger as well, so you guys can see it clearly. And I'm going to hit run, and you see it says I have 2 coconuts. So this is like an interactive IDE or this is an interactive terminal that you guys can use. So I would highly suggest to use Repple.it. For using your terminal if you don't know how to use one on your computer. Okay, so this is the situation we have here, okay? And they're showing us what this is going to do here. So let's see, they run the code as is, and it says you're going to get an error. And now, what does the error says? It says cannot concatenate string and float objects. So you can't combine the value of pi is around. So this is a string and a float number. Float number is a number with decimal values. So it says you can't concatenate these two. So we need to turn both of these into a string. So how are we going to do that? Well, we're going to wrap 3.14 in a string, and that's going to take care of it for us. The value of pi is around 3.14. Okay, so let's continue going. All right, string 1, Camelot, string 2 is place. Let's not go to %s. This is silly %s. All this does is called a placeholder. So we wrote this string here. Okay, we write this string here, and %s is gonna basically act like variables. Okay, so the first %s is gonna match with this string 1 here, and the second %s is going to match with string 2 here. So this is going to say let's not go to Camelot or Camelot, and then it's going to say tis is silly, and then string 2 is going to get inside of here, so place. So that's what that's going to say. Let's not go to Camelot, tis a silly place. Those are just, your in string formatting, those are your placeholders. So you can put anything that you want for them. Okay. Alright, string formatting %2. Raw input, what this does is it takes in data from the user and assigns it to a variable. So for example, let me open up here. Let me show you here maybe. Let's run it. Okay, so let's open up my terminal because this is not Python 2, so there are some things that it does that are Python 3 specific. Let's try it here. So name takes in as raw input. So it's basically taking in the user input. So it's going to let me type in the name, and whatever I type in, it's going to make name equal to that value. So let's say my name is Rafe or Kazi, whatever you want to type in. Let's hit enter. Now let's type name, and you can see name is Kazi. All right. And generally when you write stuff like this, you want to put a little space here so it looks nicer. So when it asks you what is your name, it puts a little space there so you can you can write whatever you want. Okay, now if I type name, you can see it's clever programmer. So that's what raw input does. Quest, same thing. It'll ask you for quest, then the message is going to say what is your quest, and then you get to type in the value that you want. Okay, so basically if I don't put any message here and make it empty, it's letting me type, but it's not telling me what I should be typing. So it's nice and more user-friendly when you actually have a message like what is your name there. Here I don't know what to type. If I wrote 43434 and did name, well, I didn't know I was trying to put in a name. I thought maybe I was trying to put in an ID number because it didn't ask me, so I just assumed. So you don't want the people that you write a program for, you don't want them to assume. You want to clearly give them instructions what they should type in. Okay, so quest is going to take in some input from you. Color is going to take in some input from you as well. And then it's going to say, so your name is blank, your quest is blank, and your color is blank. Now remember the placeholders, and we're just going to replace this with placeholders. So %s, this name is going to get into this %s here. I'm going to do %s and %s. So it's going to take in name, quest, and color by having us type it, and then it's going to put all of that in these %s's. The last thing we have to fix is this needs to also turn into, actually this is just going to be a %sign. So this is just some syntax stuff. Now let me run it. What is your name? Kazi. What is your quest? Walkthrough of Codecademy. And what is your favorite color? Blue. So your name is Kazi, your quest is walkthrough of Codecademy, and your favorite color is blue. So this is a very nice way of printing out stuff. It's really cool. Okay, next. So now there's time for review. Now for something completely familiar. Good job. You've learned a lot in this unit, including 3 ways to create strings. Okay. We learned string methods. So you can create a string by putting single quotes. You can create a string by creating a double quotes around a word. And you can create a string by putting string and not having to put the quotes around it, okay? Now you learn string methods. So if you have a string and you call the method .upper on it, everything turns into upper. If you have echo like this, let me make it more interactive for you guys. So echo lower, and if I try delta upper, you can see that it made delta in uppercase. Length of Charlie, what do you think that's going to give you? So take a second to think about it. It's going to give you 1, 2, 3, 4, 5, 6, 7. So the number of characters as in Charlie. Printing a string, print foxtrot. It simply just prints out your string. Okay. Advanced printing techniques. So golf, hotel, and then we use the string formatting here. So these little placeholders like %s, and then it takes the value of G, and this %s takes the value of H. Okay. Let's try to run that. Do you see? Golf, comma, hotel. That's what I got. So let's wrap it all up. On line 3, create the variable my string and set it to any string you like. Hello, programmers. And print on line 4, print the length of my string. So how are we going to do that? We're going to do print len of my string. And on line 5, we're going to say we're going to print my string in uppercase, okay? So that's how we're going to do that. Okay. So we created a string, hello programmers. We printed out the length of my string, which is 18 characters, and then we printed out the actual string, but we made sure we uppercased everything. So this is nice because you don't have to write caps lock. You don't have to use caps lock here. Okay, date and time. Let's start the lesson. So, cool. So date and date time. Import date time. Why is it asking me about date time? because that's a little bit more advanced. But sure, a lot of times you want to keep track of when something happened. We can also do this using datetime in Python. Here we'll use datetime to print the date and time in a nice format. Okay, cool. Getting the current time. Create a variable call. Okay, so if we do print.datetime now, so let me show you this. Okay, let's actually make this smaller because you don't need to have it that big, and just make this bigger. Okay, and let me actually, okay, that's fine. So I went ahead and I did from datetime import datetime, and now I'm gonna go ahead and print datetime.now. So it's showing you today's date and today's time. Okay, so you can do cool things. You can say datetime past is equal to datetime.now, and what you can do now is you can do, if you want to see the difference of the current time and when you started, you can do something like this. Okay, since I stored past previously, so it's gonna just have that value here. So this is basically years, month, and then the date, and then the hours and minutes and seconds, and then the seconds from 1970. So now I'm gonna do past or datetime dot now minus past. So this tells me it's been 40 seconds here. Okay, and the difference is 0 hours, 0 minutes and 40 seconds. Okay, cool. Now let's go on to the actual assignment. Okay, datetime dot now, and then print the value of now. So let's do that. Print now. Cool. So it's telling me the time now, current time. So it's saying 23 here. It's saying something different than what it said on my computer, but that's because I think this is taking the time, some other time. This is not CST. This is not Central Time. This is something else. Okay. Extracting information. So notice how the output looks like this. What if you don't want the entire date and time? What if you want something simpler? And that's what they're going to show you here. So let's actually paste that here, and let's go down here, paste those 2 lines. So we got now, datetime.now, current year, current month, and current day, and make it now.day. So if we actually do now.year, look at what it shows you. So this is now, and we're calling the year method on now. Now.month, okay, and we've stored these values in these variables. So this should give you the current year, this will give you the current month, and this will give you the current day. Okay, pretty cool, pretty cool. You already have the first 2 lines. In the third line, we take the year and only the year from the variable now stored in the current year. We store the month and date from now. Now on a new line, print now.year. Make sure you do it after setting the now variable. Okay. All right. So let's print now.year. Then print out now.month. So it's pretty much the same way as this, but we're gonna just say month, and then we have now.day. Okay, so it's gonna be pretty much the same thing, and this is gonna be day, and then that should be it. Okay, so we got the actual date time object, we took the year from it, we were able to take the month and the day. Okay, cool. Hot date. What if we want to print today's date in the following format? So if you wanted to make it look pretty, okay, kind of like this. So string substitution is now going to be helpful. So now it's going to make more sense why we use string substitution, okay? This is a little bit more helpful. Remember that the % operator will fill the %s placeholders in the string on the left with the strings in the parentheses on the right. So these guys will get filled up by these guys. So now that year is going to go into the first placeholder. Now that month is going to go into the second placeholder, and now that day will go into the third placeholder here. Okay, and we don't want it to show up with the dashes here, so I'm gonna do this. Okay, and that should work. All right, cool. I can put in something else here too, like dashes, but then it's gonna show dashes. So I want to keep it like this. So that's it for this assignment. So let's move on. Period time, nice work. Let's do the same for the hour, minute, and second. Cool. So I'm gonna pretty much take this line, paste it down here, and I'm gonna do now.hour. This is gonna give me the current hour. I'm gonna do now.minute. It's gonna give me the current minute, and I'm gonna do now.second. It's gonna give me the current second. And we don't want it to show with slashes, so we want it to look like this. Okay, you can see that's what they tell you to make it do. This is the current hour, current minute, and current second. So hopefully that was fairly simple, and it's really cool actually. I like this. Next, grand finale. We've managed to print out the date and time separately in a very pretty fashion. Let's combine the two. Okay, now let's combine the two. So we got to make it look like this. Okay, that's very easy. What I'm gonna do is something like, I'm gonna make the value of this equal to date, and the value of this equal to time, and I'm just gonna say print date plus, and let's put a little space in between, and then time, like this. And I think that should work. All right, so this is the date. I put a little space in the middle because otherwise it would all be mushed up together, and that's not what we want. We want to put a little space in the middle, and then we just concatenate all of that stuff. So the date and a little space, and then the time. Okay, so hopefully this makes sense and it wasn't too difficult. All right, now let's get started on conditionals and control flow. This is my favorite part of programming. This is when you can have your program make some really, really intelligent and really cool decisions. And this is when I like to think of, you're giving your program a brain. It's able to pick and choose and pick the best choices and avoid the worst choices, or the other way around, kind of whatever you want it to do. Here's when you can get that true power over your code. Okay, so check out the code in the editor. Let me make the screen, I think, a little bit smaller because we can't really see. So I don't like how it's written because it's making it really confusing to read it because it's running really long. I wonder if I can make the screen a little shorter, but okay, anyways. So this is how this reads. Okay, I have some function, and here's what happens in it. Print, you've just entered the clinic. And then it prints a second line. Do you take the door on the left or the door on the right? And for your answer, it's going to take in some user input. Okay, so you get to type in the answer. So this makes it more interactive here. So you get to type in the answer, and it's going to ask you, type left or right, and then hit enter. And by calling the .lower method here, whatever answer that you give it is going to take it in short case. Okay, if your answer was left or your answer was L, it's going to make that and think that you want to go left. Okay, and then it says, this is a verbal abuse room, you heap of parrot droppings. It's kind of funny. And effectively, when you go to the room on the left, that's the verbal abuse room, and the room to your right, that's the argument room. So either of the rooms I really wouldn't want to go into, but if you choose to go to left, now you've entered the verbal abuse room, and it tells you heap of parrot droppings. And if you basically picked your answer and you chose right, it's gonna say you've entered the argument room, and it says, I've already told you that, or I've told you that already. If you haven't picked left or right as your answer, or L or R, and you pick something completely different, it goes, you didn't pick left or right, so try again, and then it runs the function again. Okay, so it'll run this entire function again. That's all right? But once you've picked something, it'll end out of it. And here you're calling that function. So basically, this is the line. If you don't have this line, it's not going to run this entire thing. Okay, so let's run through this. This is going to be pretty cool. Okay, what do you think we should pick? So let's pick something completely different. Let's just say Q. Okay, so like we expected, it said you didn't pick left or right, so try again. And this time let's pick right. Of course, this is the argument room. I've told you that already. Okay, if we picked left, it would say this is the verbal abuse room, you heap of parrot droppings. So this is when you can really, give your program some fun. So some ideas to take away from this is, what if you wanted to make a game like rock, paper, scissors? So if the user put in rock and the other user picked scissors, well then rock wins, okay? Or if the other user picked paper and the other user picked scissors, then the user who picked scissors wins. So now you already have the power to make your first game, all right? So this is really the power of programming, and this is one of my favorite things. All right, so unless you learn Booleans, you won't be able to use if statements or the control flow conditionals that we were learning earlier. So let's make sure that we get this part and we learn it correctly. So Booleans are super important, and your comparator operators are very, very important. So here's all your operators. So you have equal to, you have not equal to, less than or equal to, greater than or greater than equal to. Okay, so let's run through them very quickly. I'm going to open up the terminal here, and let's go down here. And okay, let's run through them. Let's pick two values, 5, and let's make the other value 3. Okay, so 5 is 5 equal to 3? False. Is 5 equal to 5? True. Let's do, what do you think it's going to return if I did 5 not equal to 3? It's going to return true, because 5 is not equal to 3. Here, how about this? What do you think is going to return here? Yep, if you guessed it, good job. That's false. Now let's do 5 is less than 3. 5 is less than 5. That's going to return false, because 5 is not less than 5. Let's do 5 is less than 10. Okay? And now you can check, is 5 less than or equal to 10? Is 5 less than or equal to 5? Is 5 less than or equal to 4? False. Let's try, is 5 greater than 4? Is 5 greater than or equal to 4? Is it greater than or equal to 5? Is it greater than or equal to 6? False. Okay, so just to use all the operators and give you a sense of how they work. Okay, so set this to true if 17 is less than 38, or to false if it is not. So 17 is less than 328? No. Or I'm sorry, that's true, right? 17 is less. Set this to true if 100 is equal to 2 times 50. So that should be true, but let's just run it here, and we get true. And 2 times 50 is 100. So that's really saying 100 equal 100, right? And we get back true. So true. Set this to true if 19 is less than or equal to 19. So obviously this is going to be true, because, oh, I'm sorry, I should write true. Because 19 is not less than 19, but it's equal to. Set this to true if negative 22 is greater than or equal to negative 18. No, negative 22 is smaller than negative 18. So false. So let's try running it in our terminal. We got false. Set this to true if 99 does not equal 99. That's false. 98 plus 1 is 99. So we're going to get back false here. Let's run it. Cool. All right. Assign true or false as appropriate on the lines below. 20 minus 10 greater than 15. That's false. 10 plus 17 and then 3 to the power of 16. 3 to the power of 16 is going to be a huge number. It's going to be a huge number. Like it says here, 43 million. Okay, that's what that's going to be. So is 27 equal to 43 million? No. We can also run it in our terminal. And if you want to check what this is going to be, you see about 43 million. Okay, about 43 million. So this is absolutely false. 1 squared is just 1. Is that less than or equal to negative 1? No, it's greater than negative 1. 40 times 4, that's 160. Is that greater than or equal to negative 4? It's not equal to, but it's certainly greater than. So we're going to say true. Is 100 does not equal 10 squared is, remember, 10 squared, that's 100. So 100 does not equal to 100. That's false. Okay, cool. All right, create comparative statements as appropriate on the lines below. Make me true. So 3 less than 5, it makes bool 1 true. Okay, so if I just wanted to show you here, bool 1 is equal to 3 is less than 5. If I print out bool 1, it's going to show you that it's true, okay, because 3 is less than 5, right? So it's not going to give you back 3 is less than 5. It's going to evaluate the expression 3 is less than 5 and then store the result of that. So anytime you use less than or greater than or equal to or not equal to or any of these operators, you're always going to get back a true or a false, okay? All right, so let's make this false. So let's say 100 is less than 1. So now we've made this one false. Let's make this true. 100 is greater than 1. We've made this true. Let's make this false again. Let's do 40 is less than 3. And let's make this true and say 0 is greater than negative 5. Okay. We have to use 3 different operators. So we can say this and this. All right. So I just made it greater than or equal to. So I'm using the less than operator, I'm using the greater than or equal to operator, and I'm using 1, 2. I'm not using 3 different operators here. Well, I should be. So I could be using, let's just do this. 40 does not equal 3. Okay, how about that? Oh, sorry. Let's say 40. We have to make it false, remember? Okay. All right, to be and or not to be. Boolean operators. So here we're going to learn about truth tables and things like true and false is false and false and false. False and true is false. So what they basically mean here is if I took true and false, I would get back false. Okay, anytime you have the and statement, the only time you're gonna get back true is when both of the statements are true. Okay, so it's like if I asked you, let's say, do you like pizza and poison? Well, if you said yes, you would be saying yes to both things, right? You would be saying yes that you like pizza and that you like poison. So when I say and, if I said, do you like pizza and poison, you're going to say no. Even though there's only one of the things that you don't like, by saying no, you're turning down both things. So whenever I say and, both of the statements have to be true. So now let's say, do you like pizza and ice cream? And you might say yes, okay? Or you might say true. And if I ask you, do you like ice cream and poison, you're going to say false. So anytime you have and, both of the things have to be true. Conversely, if you have or, the only time or can be false is if both of the statements are false. So if I said, do you like pizza or poison? You can say true. Yeah, because, hey, you like one of those things, right? Because I said or. So you can say, yeah, I like ice cream. You know, you chose one of them. All right, so let's print out what false and true is going to give you. So think about it, right? False statement is, do you like poison? And true statement is, do you like ice cream? And here, what are you going to say? You're going to say false. No. Okay. Now, let me give you a false and a false. Do you like, what? Why isn't it pasting? I copied it. So let me give you this scenario, right? Do you like poison and do you like snakes? I mean, you could like snakes, so let's just stick with poison. Do you like poison and do you like poison? You're gonna say false. No. Okay. True or true. So remember, the only time in an or statement you can get back a false is when both of the things are false. Okay, so pretty much mostly or statement, there's a 75 or 3 out of 4 chance that you're gonna get a statement that's true. So true or true. Do you like ice cream or do you like pizza? True. Okay. Even though you're basically saying only one of them, it applies to either one. Okay. So true or false. So once again, do you like pizza or do you like whatever, right? Poison. So true because you like pizza. So in an or statement. Let's just go through a few more. And I hope that you're getting a little bit of intuition of this now. So false is false, right? The only time you get back a false is when both are false. So here you have false. Here you have a or, and here you have a true. And I think they're missing something here, and the thing that they're missing here is true, and true is true. Okay, that's what they're missing here. So the only time true, and. The only time an and statement is going to return true is when both of the statements are true. So as you see here, both of the statements are true, so you get back a true. Every other case gives you false. Any time in an or statement you can get back a false is when both are false. Otherwise, you get a true in every scenario. Okay? Not true is false, not false is true, meaning not is just the opposite. Okay, so if I did not true, I would get back the opposite of true, which is false. If I said not false, that's now is going to give me the opposite of false. Another way to write it is true. This exclamation mark means not. So not true, once again, what is that? That's the opposite of true, and you should get back false. Wait, what? Huh? Oh, in Python, you can just, I think you have to say not like this. You have to, but other languages, not is like this. Okay. What? This is, wait, I meant to say true. Huh. What? Am I blanking out here? Wow. Okay. So for some reason, I just kind of forgot. I work with lots of different languages, so I basically here forgot that in Python, I guess you just have to say not. Cool. It doesn't matter. It's very small. Okay. So here and so the Boolean operator and returns true when the expression on both sides of and are true. So remember, I cannot So this is what I kept stressing earlier. Both statements have to be true in an AND to get a true back, okay? So this makes our job real easy. So set bool 1 equal to the result of false and false. Easy. Set result of bool equal to this thing. Okay. Set results. Alright. And okay, before running it, let's try to evaluate it. Okay, tell me what you think. Do you like snakes? And do you like snakes? What is that going to return? Okay, if you said false, good job. Now let's look at this statement here, okay? So this negative, 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 they're just trying to confuse you. -2 is -2. Negative of that is +2. Negative of that is -2. And negative of that is +2. So this whole thing is really just +2, okay? All right. So +2 equal to, let's see here. Wait, did I do this right? Yeah, I did this right? -2, +2, -2, +2. -2, +2, -2. Yeah, okay, sorry. All right. Negative is equal to, so this thing it's saying is equal to this whole thing. All right, so now let's check that. So 4 is greater than or equal to 16 to the power of 0.5. 16 to the power of 0.5 is saying the same thing as the square root of 16. Okay, so that's just going to give you back 4. 16 to the power square root of 16 is 4. Basically, it's also saying 4. That's fine. Let's just leave it at that. So here is 4 equal to 4. Yes, that's true. But is -2? How about this statement here? Okay, let's check that. So this is a +2 and this is a -2. What do you think this evaluates to? False. Okay, so you have false and true. What do you think you're going to get? If you said false, good job, because both of the statements have to be true. All right, now let's evaluate this guy. So let's start off from right here, okay? 19 modulo 4 does not equal 300. That's right. 19 modulo 4, what is that going to give you? Think about it. 4 goes perfectly into 16, but 4 does not go into 19 perfectly. So you have a remainder of 3. So it's saying 3 does not equal 300. Well, that's true, right? 3, I'm sorry. I'm reading it wrong. It should be like this. So 300 divided by 10 is actually 3. So if I showed you guys 300 divided by 10, that's 30. That's divided by 10, that's 3. So here we're getting back 3 does not equal to 3. That's false. And we have false here. So false and false, what will that give you? Right? What will that give you? Do you like when there's bubble gum stuck underneath the desk? And do you like when there's a bubble gum stuck underneath the desk? So false. No, I don't. All right, so this whole thing is going to evaluate to false. Let's go with this guy here. 1 to the power of 2, that's 1. That's -1. And is that less than 2 to the power of 0? -1 is less than, so 2 to the power, anything to the power of 0 is just 1. Okay, so -1 is less than 2 to the power of 2 to the power of 0, that's 1. And 1 to the power of 2, that's 1. And then we have -1, okay? So is -1 less than 1? That's true. And 10 modulo 10, what does that give us? That gives us 0. Is that less than 10 times 2, which is 20? 20 minus 20. So yeah, 0. And then 20 minus 20, that's 0. So this whole thing, so 0 is less than or equal to 0. And this is -1 is less than 1. So this is true. And this whole part is true. True and true, what does that give you? It gives you true and true and true. What does that give you? That gives you true. Okay. All right. So that was just some practice with those statements. Okay, so here, if you also want to just try running it and see what you get, your computer can evaluate it very easily. And here, once again, the same kind of things are happening, but it's with an OR statement. So what does this part evaluate to? Just to be quicker, let's do it like that. So 2 to the power of 3 gives you 8, and 108 modulo 100. 100 goes perfectly into 100, and then there's 8 left over. So this gives us back 8, and this gives us back 8. So this whole part of the equation is true, and then true OR. But does Cleese equal King Arthur? No, they're two different words. They're two different names. That's false. So here we have true or false. What's that going to evaluate to? That's going to evaluate to true. Okay, so let me write that. True. True or false, what is that going to evaluate to? Remember, the only time OR returns a false is when you have both things being false. Okay, so here, this is true. Just to prove it to you guys, let's grab this and run it. Cool. 10. So basically, what to the power of 2 gets you 10? That gets you 100. Square root of 100 is 10. And is 10 greater than or equal to 50? That's false. False or false will get you a false, right? That's the only time false will return a false. True or true, obviously that's true. This is false. And what is this going to be? 1 to the power of 100 is just 1. 100 to the power of 1 is 100. This is a false. 3 factorial, so here 3 times 2 is 6. We can ignore that. So 6 does not equal 6. So that's false. So here both of these are false, and we get back a false. Okay, cool. So I just did that for practice. And then now they're going to show us how to use the not operator here, okay? Not true. Remember, that's just the opposite of that. These are all just opposites, so there's nothing hard here, okay? This is really simple. I'll teach you guys how to think about it. So here's how to think about it, okay? So anytime I see a not in my head, I just put a parentheses for everything that comes after it in my head. So I'm going to just put it right here so you guys can see the parentheses. So here's how I think about it. True. So once I evaluate this whole thing, then I just put a not. So I just get the opposite of that. So true. False. 3 to the power of 4. What is that? It's 3 to the power of 4. That's 81. And what's 4 to the power of 3? That's 64. Is 81 less than 64? No. So that's false. So this whole thing is false. And then we just put the opposite of that. So opposite of false is true. So let's try running it. Got back true, right? True. False. Same thing here, right? 10 modulo 3, we get a remainder of 1 because 3 goes perfectly into 9. And then we have a remainder of 1 there. And 10 modulo 2, here we have remainder of 0. So we're saying 1 is less than or equal to 0. That's false. Not false is true. Okay. So this is going to give us back true. Let's try this guy here. 3 squared. 3 squared is what? What is 3 squared? 9. Okay. So you don't have to be good at math to be a programmer, by the way, guys. You see, my math is not my strongest asset. So 3 to the power of 2 plus 4 squared, it's going to be 16, and 5 squared, 25. So here, 16 does not equal to 25. That's, no, hold on, I'm sorry. You're going to first get the expression of this, and then you're going to evaluate this guy separately, okay? So 9 plus 16, that's 25. And this is 25. So 25 does not equal 25. That's false. And not false is true. So true here too. Okay, that's what we got, true, when I ran this computation here. And not false, so here how I would do it is like this. Okay, and then put a parentheses around this guy. So false, once I evaluate this guy, that's just simple. I pretty much, in my head take it out of parentheses. Not false, that whole thing turns into true, and then not true turns into false at the end. Okay. Okay. Cool. So true and then false again. Okay. Like that. All right, let's start next lesson. This and that, or this but not that. Cool. Not is evaluated first, and is evaluated next, or is evaluated last. Okay, or is evaluated last, and not is evaluated first. So now let's do some examples. So not true, that gives you a false. False and true, that whole thing gives you a false, right? Let's run it. That whole thing gives you a false here, and then false or false will just give you a false. That's the only time an or statement will give you a false. Let's grab it and run it. You can see you got a false. Cool. Whoops. Okay. False and not true or true. So here we have not true, that's false. Now we're going to evaluate the and statement. Okay, so not true, this is going to get us false. False and false is false, and false, this whole thing is false. False or true is just, it's true. Alright, you got back true. And at the end I have a comment there. Even if I don't have it, it doesn't matter. We just tell our code to ignore this part. So we got true. Okay, cool. Let's go through the last few. Alright, true and not. Okay, so false or false is false. Not false. Oh. Yeah, I mean it's parentheses, so we have to evaluate it. False or false is false. Not false is true. True and true is true. So we're gonna get back true on this guy here. So let's try running this guy. True. Bool 4. Alright. Not true. This is false here. So we'll keep a mental check here. So this is false. False and false is false. So this whole thing turns into false. And now this whole thing is false, okay? And not true is false, and not false is true. So this whole thing is true, this whole thing is false. True or false will return true. Okay. So I hope you're getting a sense of how to evaluate these actually. Okay. And bool 5, let's try that now. True and true is true, not true is false. False or false is false. That's the only time false is false. Okay. Alright. Cool. And we're done. Let's move on. Okay. So this time we'll give the expected result, and you'll use some combination of Boolean operators to achieve that result. Remember, the Boolean operators are and, or, and not. So those are the Boolean operators, okay? The other ones are comparators or comparison operators. So less than, equal to, equal to. And don't confuse equal with equal, okay? This is something I just want to talk about really quickly. So if I did Boolean is equal to false, now if I printed out bool, it's going to say false. Let's say your name is equal to John, okay? I don't know if you're John or not, but let's just say that. Now if I did your name, it's going to print out John. So the one equal sign is an assignment operator. But if I do two equal sign, it's a logical operator. Okay, so let's say I made your name equal to Kazi. So now if you did your name and you got Kazi, and now let's check if your name is equal to John. So this is checking, is this variable your name equal to John? False. Okay, so the double equal sign will always return a true or a false, and the single equal sign will actually assign the value. So single equal sign is an assignment operator, and double equal sign is a comparison operator. All right, so here they made some combination of Boolean operators, which is and, not, or, to make this a false. Okay, so we are going to create something that's going to make this statement a true. So I can say true and true. I can say false or false. I can say true and true. And I can say false or true. Right? Or how about this? Not true. Cool. So we did 50 exercises and we got a badge for it. Okay, cool. We're making good progress. Now before we move on, let's see where we are currently so we can get a sense of where we headed. So let's go. So we finished Python syntax. We finished the tip calculator. We're not going to do this because you have to pay extra for this. And string console, date and time. And we are currently working on conditionals and control flow. After this, we're going to do Pig Latin. What do we have left? Functions, lists and dictionaries, student becomes a teacher, more lists and functions, and loops. Loops are awesome. Exam statistics, advanced topics in Python, and introduction to classes, file input and output. Awesome. So we have a long way to go. So let's keep going. Let's keep plowing through this.